Hi, hello and Assalamualaikum. In today's video, our group will be presenting about application of differentiation, which is related rates. First thing first, let's meet our group. Let's start with Akil Izzuddin, Muhammad Naufal, Shakira and Halumi. Let's begin. What is differentiation? Differentiation is a method of finding the derivative or rate of change of a function. Techniques to solve differentiation problems is derivative of sum and difference, derivative of a product functions, which is product rule, derivative of rational functions, which is quotient rule. Functions can be defined as dy dx, fx, and y. There are 5 applications that we have learned, which is analysis of functions 1, increase, decrease, and concavity, analysis of functions 2, relative extrema, first and second derivatives, related rates, maximum and minimum problems, Rolle's theorem, and mean value theorem.
Okay, now let's talk about related rates. What is related rates? Related rates problem are word problems where we reason about the rate of change of a quantity by using information we have about the rate of change of another quantity that relates to it. The related rates technique is an application of the chain rule. Related rates and implicit differentiation are interchangeable methods. Related rates are useful when we are looking at the two variables related by some constraint or equation and both are varying with time. There is 4 steps in solving related rates problem. First, draw a picture of the physical situation. Then, write an equation that relates the quantities of interest. Use chain rule to differentiate both sides with respect to time. Lastly, substitute all known values and solve them. Problem statement. The radius of a spherical balloon filled with air increase at a rate of 0.5 per second. Find the rate of change of its value when the radius is 4 cm.
Before we start, we need to understand the problem. The radius of a balloon being filled with air increases at a rate of 0.5 cm per second. Find the rate of change of volume of the balloon when the radius is 4 cm. Second, we need to plan the strategy by let r cm be the radius and v be the volume of the balloon respectively at time t second. Form an equation relating the volume v to the radius r of the balloon and use the chain rule to relate the rate of change of volume to the rate of change of the radius of the balloon. So let's start the strategy by let v equals to fr. The rate of change of volume is given dv over dt equals to dv over dr multiply dr over dt. It is known that balloons are spherical, so volume is 4 over 3 pi r volume. R radius equals to 4, dr over dt is radius equals to 0.5. So by using sphere formula 4 over 3 pi r volume, we differentiate them and equals to 4 pi r square. Next, with our answer earlier, need to multiply with dr over dt, which is 0.5. Where did it come from? It comes from by the answer given. And then we got 4 pi r, which is equal to 4 square multiply with 0.5 equals to 64 pi multiply with 0.5 and then equals to 32 pi. The pi we need to change it to the number which is 3.142. Then we got 32 multiply with 3.142 and we got the last answer, which is equal to 100.5. So the result show when R equals to 4 and dV over dt equals to 100.5. It means that when the radius of the balloon is 4 cm, its volume increase at the rate of 100.5 cm volume per second.
Conclusion. We can conclude that application of differentiation can be used to define a value of a volume, solve any kind of problem in our daily life, and solve problem related to value of volume. Acknowledgement. We are really grateful because we managed to complete this video presentation within the time given by our lecturer, Madam Husna. This assignment is impossible to be done without the amazing cooperation and effort from our group members, Akil, Naufal, Shakira, and Halumi. We also sincerely thank our lecturer of Calculus 1, Madam Husna, for the guidance and willingness to help us in what we are lacking when completing this assignment, and surely for teaching us this course. Last but not least, we would like to express our gratitude to our family members who keep on encouraging us all the time. Reference. We have 3 references that we use to help us in presentation videos. Thank you for watching our presentation videos.